This is practice problem number 4, cows and chickens, from lesson 11 on both of the lines, and this is unit 4, linear equations and linear systems. And this is a classic problem, cows and chickens, for looking at two equations and what value of x solves both of those equations. So what value is on both of the lines for the number of animals and the lines for the number of legs, which you'll see in a moment. So we have a farm that has chickens and cows, and all the cows have 4 legs and all the chickens have 2 legs. Altogether there are 82 cows and chicken legs, so 82 legs altogether on the farm. Complete the table to show some possible combinations of chickens and cows to get 82 total legs. And the classic way of stating this problem is that someone looks underneath a fence and they count the number of legs, and then they look above the fence and they count the number of heads. And the number of heads is the number of animals, and certainly the number of legs underneath. So they're going to give you different numbers of animals, but every combination has 82 legs. So 35 chickens, but let's look at some equations just for a moment. So the number of legs from cows is there are 4 legs for every cow, so the number of legs is going to equal 4 legs times the number of cows. So 4 times the number of cows. We're using W for cows. W is for the Y value. And chickens, the number of legs from the chickens is 2 legs for every chicken, so 2 legs. So 2 times the number of chickens is going to give you the number of legs from the chickens. And K is going to be the X value along the X-axis. Combine these two into an equation. So 4 times the number of cows plus 2 times the number of chickens will give you the total number of legs. In this case, they're telling you what that is. That is 82 legs. All right, so now we can fill this table in. So let's say you have 35 chickens. That is equal to 70 legs. 2 times 35 is 70, and you've used up 70 legs out of the 82 that you have. So 82 minus 70 is 12 legs left. So how many cows is that? Well, every time you take out 4 legs, that's equal to a cow. So how many times can you do that? That's 12 divided by 4 is equal to 3 cows. If you have 7 chickens, then you have 14 chicken legs. And so that you used up 14 out of the 82. 82 minus 14 is 68 total legs for the cows. Well, how many cows is that? Once again, every time you take out 4 legs, that's a cow. So 68 divided by 4. How many times can you do that? You can do that 17 times. So you have 17 cows. But let's say you have 10 cows now. How many legs is that? Well, 4 times 10 is 40 legs from the cows. So you're using up 40 legs. You have 42 legs left for the chickens. So every time you take out 2 legs, that's a chicken. So 42 divided by 2 is equal to 21 chickens. You can do that 21 times. 19 chickens, 2 times 19 is 38. Used up 38 legs. You have 44 left. 44 legs divided by 4 legs for each cow gives you 11 cows. And finally, 5 cows. 4 times 5 is 20 legs from the cows. Using up 20 legs, you have 62 legs left. 62 legs divided by 2 legs for each chicken gives you 31 chickens. Okay, now the idea is to then look at the relationship between this table and the graph. And so here's the graph. Now this is the graph of just one single combination. The number of animals is 30 animals. So that row is right here. 19 chickens plus 11 cows. This is the row that gives you 30 total animals. So the answer, that's going to be the answer to this problem, is the point at where the chickens is 19 and the cows, the point where the cows is 11. So 19, 11 on this graph. So over here, 19, and we're going to go up here to 11. The answer is going to be right there. So let's see how we get that. So the nice thing about the standard form of an equation, so this is ax plus by equals c. This is the standard form of an equation. So the nice thing about that is if they're giving you the answer here, c, then if you just make the number of cows in this case is 0, so all the legs come from the chickens, that means you have to have 41 chickens. So chickens is 41, and likewise, if you make the number of chickens 0, all the legs come from the cows, so 82 divided by 4 is 20 and a half cows. So this is 20 and a half. And if you connect those 2 points, every point on this line is equal to 82 total legs. So see, these are the different combinations of cows and chickens that equal 82 legs. And this point right here is the combination of 30 cows and chickens that give you 82 legs. It's the only time that these two lines intersect, so this is the only combination of 30 animals, 30 cows and chickens together, that will give you 82 legs, and we know that the answer is already is 19 chickens and 11 cows. But let's continue to look at that. So I'm going to write both of these equations in terms of chickens. So this is W equals a negative 2/4 times the number of chickens. So the number of cows is a negative 1/2. Remember, that's a negative 1/2. So if you move over one chicken, so I'm going to give you one chicken, you're going to give me a half of a cow. So remember, we have to keep these legs the same. So one chicken is 2 legs, a half of a cow is 2 legs. So if you were to give me 2 chickens, I'd have to give you 1 cow to keep the number of legs the same. So that would be 4 legs from the chickens and 4 legs from the cow. 8 legs from the chickens, 4 times 2 is 8, and 2 cows is 2 times 4 is also 8. So you want to stay on this line, which is 82 legs. So that's the point here. So that slope in every case is a negative 1/2. It's the change along the y-axis, which is 1 unit, a negative 1 unit in this case, over the change along the horizontal axis, or the x-axis. It's a positive 2, so that slope is a negative 1/2. Same here, a negative 2 over a positive 4, negative 1/2. Same here, a negative 1/2 over a positive 1 is a slope of negative 1/2. So this slope is a negative 1/2 times the number of chickens. And remember, you have to add this 20 and a half to that. So to get the number of cows, you figure out the relationship with the number of chickens. But remember, it starts up here at a positive 20 and a half. So you're going to be subtracting cows each time you add a chicken. So 1 chicken, you're going to subtract half of a cow. 2 chickens, you're going to subtract a whole cow. So you subtract half of a cow, subtract a whole cow as you go down this. And this is the equation for this line right here, the total number of animals. And this makes sense, it's the number of cows plus the number of chickens equals 30. So if I write that in terms of chickens, the slope is a negative 1. So it's going to be the opposite of how many chickens I have, plus 30 is going to tell me the number of cows I have. So let's say that again. So if I have 25 chickens, the opposite of 25 is a negative 25. You add that to 30, and that tells you that you have 5 cows. And that makes sense. 25 chickens and 5 cows. And that point would be right here, 25 chickens and 5 cows. But again, the only time that these 2 points intersect is when you have 19 chickens and 11 cows. Now the way to figure that out algebraically, using the algebra, is to set both of these equations equal to the number of cows. We're going to solve for k. So the number of chickens that make both of these equations equal to each other. So this point right here. So get rid of the number of cows. And so we're left with the number of chickens. So we're going to solve for that. So you have 30 animals. That's this equation right here. And you have 82 legs. That's this expression right here, I should say. So this expression and this expression, if you set them equal to each other, you get this equation, and you solve for the number of chickens, k. Now watch what happens. We're going to look at the graphs at the same time as we solve this equation. So if I subtract, and I usually like to have these answers as positive values. So I looked at this 30 and 20 and a half, so I'm going to subtract the 20 and a half from the 30, and that means I'm going to subtract the 1/2 k from the 1k. Actually, I guess I did that one first. So I'm going to add 1k to both sides, so I have 1k minus 1/2 k right here. It's going to give me a positive 1/2 k, and it's 30 minus 20 and a half here, so it's going to give me a positive 9 and a half. Now it turns out that that's not the best thing to do in this case, because this is really a negative. First of all, let's look at this difference. So 30 minus 20 and a half is 9 and a half, but this is a negative 9 and a half. You're going this way down from 30 to 20 and a half. So it would be better if I solve these. So I was writing a negative 9 and a half equals a negative 1/2. Okay. It just has to do with how I chose to solve it. You can do it either way. You still end up with looking at this distance from this point to this point. You're going to divide that by 1/2. How many times can you take 1/2 out of this? I'm going to talk about that right now. Okay, notice that if I trade one chicken for one cow, this is a 1 unit. This 1 unit is 1 unit closer to this 20 and a half. But notice that at the same time you also move over 1 chicken, but this is just half a cow. You have to keep the number of legs the same. So 1 chicken, 2 legs. This is a half of a cow, 2 legs. So this moves farther apart by 1/2 of a unit. So this moves closer by 1 unit, farther apart by 1/2 of a unit. So how far do they move? How much closer do they get for each chicken? They get 1/2 of a unit closer. So you're going from 9.5 units. This length right here is 9 units. So you've moved 1/2 of a unit closer. This is going to be 8.5 units. This is going to be 8 units. So how many times? So each time you trade 1 chicken for either 1 cow, well, a combination of 1 cow and a half a cow here, you have a net gain of enclosing this length of 1/2 of a unit. So how many times can you do that? 9.5 divided by 1/2. I'm going to say that again, same idea. So it's 9.5 equals 1/2 k. So this negative 1 right here, so 1 chicken for 1 cow, this is 4 legs closer. But this is 1 chicken for half a cow. Remember, you want to stay on the 30 animal line, and you want to stay on the 82 leg line. So 1 chicken for half a cow, this is 2 legs farther apart. This is moving 2 legs farther apart. This is moving 4 legs closer. So the net gain, the net movement closer, is 2 legs, which is half of a cow, which is a whole chicken. Every trade of a cow for a chicken is a gain of 1/2 of a cow. So that means, so how many times can I do that? How many times can I take a half of a cow out of 9.5 cows? And remember that each half of a cow is equal to 2 legs, which is equal to 1 chicken. So that's going to tell me how many units I can go this way once I do that calculation. So 9.5 divided by 1/2 is 19 halves divided by 1/2, which turns out to be 2 times 19 halves, which is 19 chickens and 11 cows. And that's the answer that we were saying all along it would be. So from the graph, you can see it's 19 chickens and 11 cows. So what you're doing, let me just repeat that just for a second. You're figuring out as you move down this line of the total number of animals, and you move down this line for the total number of legs, you're keeping the number of legs the same, always 82, and you're keeping the number of animals the same, always 30. And as you make those trades, this is getting a half of a cow closer, or you're adding 1 chicken each time. So how many times can you do that? You can do that 19 times. So you'd go out here 19 times, and these two lines will intersect. That means at the same time there are 82 legs and 30 animals. So the second part of this, or the next part of this problem, was to figure out how many chickens and how many cows you have. Well, if you have 19 chickens, that's solving the equation. The number, or k equals 19, or x equals 19 if you use x and y. So the number of cows is 19 plus whatever number of cows there are equals 30. So 30 minus these 19 chickens is going to give you the number of cows, and that equals 11 cows. These are the two lines they're talking about right here. So is this point on both lines? That's the title of the lesson. So this point is on both lines when it's at 82 legs and 30 animals. This finishes the problem. So you can stop here. I'm going to go into some detail to look at this problem in a little bit more depth, actually quite a bit more depth, but you can stop here if you want, or you can continue to listen to and watch the video. This is the first extension for practice problem number 4, cows and chickens, from lesson 11 on both of the lines. So there are more than one line. Basically, there are 2 lines in these problems, and from unit 4. This is a system of equations, this linear system of equations. And so in this extension, I'm going to talk about parallel lines, and also we're going to see what happens when we go from 24 animals and 82 legs to 30 animals and 82 legs. We're going to move along the graph of those equations and see what happens as we make that move. So this is the graph that we started out with, and I just wanted to review for a moment that we used the standard form of the equations to begin with. So the standard form is ax plus by equals c. So for the number of legs, it was a times the number of chickens plus b times the number of cows equals the total number of legs. And for the total number of animals, it's k plus w equals c. And I want to use c in both cases, the total number of animals and the total number of legs. And when we do that, we use this symbol called prime. So I'm using the same variable, but it has 2 different meanings. So in one case, the total number of animals is going to be c prime. In the second case, the total number of legs, so 2 times the number of chickens plus 4 times the number of cows equals c double prime is what we call that. And the nice thing about the standard form is to graph the equation. It becomes pretty easy. You just make one of the variables 0. So let's make chickens 0. That means that cows are going to equal 30 animals. So if chickens are 0, then cows are 30 animals. And if cows are 0, so you just make cows 0 to w 0. So you have 1k, 1 times the number of animals equals 30 animals. So that means that all of the animals are chickens. So cows are 0 and chickens are 30. And it's the same for the number of legs. If you make the number of chicken legs 0, then all of these legs, all of these 82 legs comes from the cows, and 82 divided by 4 is 20.5 right here. And if you make the number of cows 0, then all of these legs come from chickens, so 82 divided by 2 is 41 chickens right here. So this is the graph for 82 legs, and this is the graph for 30 cows. And the goal was to find this point where it intersects. That means that you have, at the same time, you have a combination of 30 animals, 30 cows and chickens that have a total of 82 legs. And that answer, that combination, is 19 chickens and 11 cows. So that's the idea of solving a linear system of equations, finding this point where they intersect. Now I want to talk about movement along these lines. So moving from 20.5 cows along this line, so where you keep the number of legs as 82 legs, and you reach this point, or movement along 30 total animals, and so you keep the total animals 30 animals, and again you reach this point of intersection. So how do you do that? How do you close this gap and get to this point of intersection? What's the thinking that goes through that? So this is a graph of all of the total number of animals from the table. So we had 24 animals, 30, 31, 36, and 38. And this graph right here is the total number of legs. So A, B, C, D, and E is the table. So you had 24 animals, 82 legs, 30 animals, 82 legs, 31 animals, 82 legs, 36 animals, 82 legs, and 38 animals, 82 legs. So different number of animals, to have 82 legs, you have to have a different combination. And that is these points, A, B, C, D, and E. Now what if you change this to 100 legs? So this is the combination of animals that total 30 animals that have 100 legs, or a combination that has total of 31 animals, again 100 legs, 36 animals 100 legs, and 38 animals 100 legs. Now notice that the 24 animal line does not intersect with the 100 legs, because the highest number of legs that you can have with 24 animals actually is 96 legs. You can't get to 100 legs. So 4 times 25 is 100, 4 times 24 is 96. You can't get there. So these two lines do not intersect, so there is no answer for 24 animals and 100 legs. So this is the table that goes with those graphs. And so I would suggest that you just go through the activity of filling in this table and the first 5 rows, and look at the graphs, of course. But the first 5 rows are the table that you already did. And we're going to add to that 100 legs. So the number of cows and chickens that give you 100 legs for 30 animals, 31 animals, 36 animals, and 38 animals. So go through that activity, go through the arithmetic to fill in this table. And then the next question I want to look at is, what happens if you go from 24 animals and 82 legs to 30 animals at 82 legs? Now we can solve this a couple different ways. But first of all, what I want you to notice is when you look at all the lines for the total number of animals, they are all parallel. So why are these lines all parallel? And it is because they all have the same relationship of 1 cow for 1 chicken. So we're going to trade 1 cow for 1 chicken, or 1 chicken for 1 cow. So I'm going to add a chicken, subtract a cow, add a chicken, subtract a cow. So that is a slope of a -1. Add a chicken, subtract a cow. And it's the same for each of these lines. So since they have the same relationship between cows and chickens, they have the same slope. So this is adding a chicken, subtracting a cow, adding a chicken, subtracting a cow, adding a chicken, subtracting a cow. It's the same for 36. If I want to keep this as 36 animals, if I add a chicken, then I have to subtract a single cow. If I want to keep this as 38 animals, if I add a chicken, then I have to subtract a cow. So that slope is -1. And notice for the number of legs, the slope is also the same. So these two lines are parallel, because the relationship between the number of legs and then from chickens and the number of legs from cows is the same. That relationship doesn't change. You have 2 legs per chicken and 4 legs per cow. So if I trade 1 chicken, I'm going to get a half a cow. So if I add 1 chicken, that's adding 2 legs. That means I have to subtract a half a cow. That's subtracting 2 legs. Because notice that the legs remain the same in this case. The legs remain the same in this case. So if I add 1 chicken, I have to subtract a half of a cow. If I add 2 chickens, I have to subtract a whole cow. Add 2 chickens, because that's 4 legs. Subtract a whole cow, that is 4 legs. Now these lines, the graphs of those equations, those lines, are in the background of an infinite number of legs, which are the red lines, and an infinite number of animals, which are the blue lines. So right here, this is one animal, so 1 cow, 0 chickens, or 1 chicken, 0 cows. Go up to 2 cows, 0 chickens, or 2 chickens, right here, a little bit hard to see, and 0 cows. And the red lines are the total number of legs. So if you have 1 cow, you have 4 legs. But if you have 2 chickens, you also have 4 legs. So this is the graph. This is the graph for 4 legs. This is the graph for 8 legs. If you have 2 cows, you have 8 legs. And if you have 4 chickens, you have 8 legs. A little bit hard to see. I just want you to see that we start putting together these tables, we start putting together these graphs. We're just pulling out one example of many different possible combinations. And this is the combination for 30 animals. So this line is all the different combinations to have 30 animals between cows and chickens. And this is the line to have all the different possible combinations to have 82 legs. And every time it crosses a blue line, that's a different combination, a different total number of animals, and a combination of cows and chickens, until you get to this blue line, which is 30 total animals, and that combination of cows and chickens equals 82 legs. And that answer was 19 chickens and 11 cows, right about here. Hard to see in this background. All right, so this is the 100 legs right here. And if you had 30 animals and you had all cows, how many legs would you have? Well, you'd have 120 legs. This graph right here is 120 legs. This is 30 cows. But if you have all chickens, so now you go along this line for 30 animals down to here. This is all chickens. How many legs do you have? You have 60 legs. So this is 60 legs. This is 182 legs. I'm sorry, 82 legs. This is 100 legs, and this is 120 legs. So the number of legs are decreasing as you move in this direction. So you're changing from all cows to all chickens. And as you make that change, 1 chicken for 1 cow, you decrease the number of legs. So that here's 100 total legs, here's 82 total legs, and here's 60 total legs. If you pull out one example here, if you go to 29 chickens and 1 cow, how many legs is that? It's going to be this green line. Let's get rid of all that background. So I make a trade. I'm going to remove 1 chicken and add 1 cow. So how many total legs is that? So if I remove a chicken and add a cow, I'm going to add 2 legs. A cow has 4 legs, a chicken has 2 legs. I subtract 2 legs, I add 4 legs. That's a net gain of 2 legs. So instead of 60 legs, I'm going to have 62 legs. So this line right here is 62 legs. So 4 times 15.5 is 62. 4 times 16 right here, if I have 16 cows, that's going to be 64 legs. So that's going to be 1 more trade. So I get rid of 1 more chicken, add 1 more cow, and it's going to go up to right here. So it's going to be, sorry about that, but this is going to be at 16. So it's going to be 2 legs more. All right. So let's look at what happens. So here are all the number of animals. This is 82 legs. Let's look at what happens if we look at this point, which is 24 total animals and 82 legs. And we're going to move along this line until we get to 30 total animals and keep the number of legs at 82 legs. So what's going to happen is we're also going to be on this line, which is 30 animals. So we're going to move, because we want to get to 30 animals down here. So we're going to move along this line, keeping the number of animals at 30 animals. So the number of legs are going to change. until you go to from this number of legs, we'll figure that out in just a moment, to 82 legs. Along this line, the number of legs is going to stay the same. The number of animals is going to change until you get from 24 animals to 30 animals. Now it's useful to figure out this number of legs because we're going to move from that number of legs to 82 legs. And what number of legs is that? This is 23 cows. 4 times 23 is 92. It's 80 plus 12, or 92. And 2 times 7 is 14. So 92 right here plus 14 is 92, plus 10 is 102, plus 4 more. So this is 106 legs right here. So 106 legs. So we're going to move from this point to this point and move from this point to that same point. That is where you have a combination of cows and chickens that have 82 legs and 30 animals. All right, so to get there, let's just move along this orange arrow for a moment. I'm going to trade 1 cow for 1 chicken. I'm going to do that 12 times. I'm going to tell you how I know it's 12 times in just a moment, but we want to stay on this line of 30 animals. I'm going to zoom in, stay on this line. So we're going to trade, we're going to add 1 chicken and take away 1 cow. So that's going to keep this at 30 animals, but if I add 1 chicken and take away 1 cow, then I'm removing 2 legs. So 1 chicken is, I'm adding 2 legs, and I'm taking away 4 legs. Well, I need to get from 106 legs to 82 legs. That's 24 legs that I have to remove. Well, if I remove 2 legs a time, every time I add a chicken, well, 24 divided by those 2 legs means that I have to add, I think I said that wrong. I remove 2 legs every time I add a chicken. That means I have to add 12 chickens to get to those 24 legs. One way to think about it, we're going to look at some algebra in just a moment to show that. But here's adding 1 chicken, removing 1 cow, and that's keeping the same number of animals, but you're removing 2 legs at a time. Okay, now this line, I'm going to stay on this line for 82 legs. So I'm going to add a chicken and remove half of a cow. So now the number of animals is going to increase because I'm going to add 2 chickens and remove 1 cow. So I'm adding one more animal 6 times. And that makes sense. I'm going from 24 animals to 30 animals. So I'm going to do this 6 times. Add 2 chickens, remove 1 cow. Add 2 chickens, remove 1 cow. Add 2 chickens, remove 1 cow. Right about that mixed up here. Add 2 chickens, remove 1 cow. So trade 1 cow for 2 chickens 6 times. So you want to stay on this line, and you're going to gain 6 animals or 6 chickens. Now, here's the slope here. So I'm going to remove a cow. So that's going to close this gap by 1 cow. This is going to be 1 cow closer, but down here, I'm going to remove a half of a cow. So that's going to make this gap 1/2 of a cow farther apart. So this is 1 cow closer, a half of a cow. This is a -1, but now it's going to inch forward. It's going to be widened by a half of a cow. So it's a -1/2. So that gain, how much is this closer? It's closer by a half of a cow. This is a -1, or this is 1 unit, and this is a half a unit farther apart. So you take this 1 and you subtract this half of a unit. So the amount that they get closer together is 1/2 of a unit, or 1/2 of a cow. A little bit hard. 2 chickens, 1 cow. All right, the slope is -1. Slope right here is -1, 1 cow closer. This slope is -1/2 right here. This slope is a -1/2, so it's 1/2 of a cow farther apart. So that difference, this is the difference in the slopes. That difference is a -1 minus a -1/2. So the slope for the total number of animals is -1. The slope for the total number of legs was -1/2. So that difference, -1 minus a -1/2, is a -1/2. That's the gain. How much it gets closer together is 1/2 of a cow. So it goes from -6. So this distance from this point to this point now is a -5 1/2. The distance from this point to this point is going to be a -5. So each time it gets closer by 1/2 of a cow, which is 2 legs. So every time it gets, for every chicken added, it gets closer by 2 legs. We need to gain 24 legs. Lose 24 legs. So 24 divided by 2 are those 12 chickens. So it gets closer by 2 legs, or 1/2 a cow. This is now a -4 1/2, a -4, and it's going to continue until this gets down to 0. And how many times is that going to be? That's going to be 12 times. So that is that -6 divided by a -1/2. I'm going to show you where that shows up in the algebra in just a second. But -6 divided by -1/2 are those 12 chickens. So you're going to add 12 chickens. And we're going to get rid of 6 cows. So subtract 6 cows, add 12 chickens, and you get to this point right here. Now, this is the original problem. Originally, we went from, we stayed at 30 animals, and we went from having 30 cows and 0 chickens to, so this would be 120 legs to 82 legs. Well, that algebra was this difference, 30 minus 20 1/2. So right here, I'm going to look at it as 20 1/2 minus 30 was a -9 1/2. And then the slope, the difference in the slopes, if you remember, this was -1 and this was -1/2. So this is a -1 minus a -1/2, or plus a +1/2. Either way works. This is a -1/2 times the number of chickens equals a -9 1/2. And then you divide by -1/2, and that ends up being 2 times this 9 1/2, which gave you a number of chickens of 19, this point right here. And the total number of animals was 30. So if it's 19 chickens, it had to be 11 cows. Now, in the second part of this, where we went from 24 animals to 30 animals, we're actually starting right here. So how do I solve this algebraically if I'm starting right here? Well, if I rewrite the graph, redraw the graph where I make this the y-axis, then this difference is those 6 units. And I'm taking out a 1/2 a cow at a time, so 6 divided by 1/2 is equal to 12. So I'm going to be 12 units farther from this line. So algebraically, it looks like this. New equations. So the total number of animals now is 23. This y-intercept becomes 23. This y-intercept becomes 17. So a -1/2 k plus 17 right here. This line right here, from this being the new y-axis. It might be a little bit confusing. The only point is that we're moving from this line now to this point of intersection. And I want to show you that algebraically. So here's the -6. So it's 17 minus 23. That's this 6 units right here. It's a -6 units. And here's the -1/2. It's still a slope of -1 and a slope of -1/2. That difference is a -1/2. And then we said you're going to divide this 6 by 1/2. That's the same as this -6 divided by this -1/2. So it's a -2 times a -6, which is the same as 2 times 6, and that gets you these 12 chickens. Now in this case, you have to add the 7. Remember, we slid this axis over 7 units. You have to add those 7 units back. So 12 plus 7. So this 12 plus this 7 gets you out to the 19 chickens that we had originally, and it's still 11 cows. So this finishes the first extension. Now, this is a lot, and I'm going through a lot of stuff. I'm just trying to get you to see the movement along these lines and how it relates, how you relate the graphs to the equations. This is extension number 2 from practice problem number 4, cows and chickens, lesson 11, on both of the lines, which once again means that there are 2 lines. And we're looking at the intersections of those lines. That's called a system of linear equations. And in extension number 2, I became interested in what happens or how you move along these lines if you want to go from 36 animals, which have 82 total legs, to 30 animals, which have 100 legs. So it's interesting to me because we're reducing the number of animals and we're increasing the number of legs. And how do you solve this problem, both just through reasoning and algebraically? And I came up with a couple different ways of doing both. And algebraically, in the beginning, I was moving from the left to the right. So starting with the y-axis and moving to the right on the graph. And ultimately, I started thinking about, well, can I move from the right to the left on the graph? So this gets way out there. I know that. And I'm going to divide this extension into 4 parts. And I'm going to insert one of these pink slides in between each part as we go through this. So in the beginning, we have, this is a part of the table. I have 36 total animals and 30 animals, 36 total animals with 82 legs, and 30 animals with 100 legs. So this is 36 animals right here with 82 legs, and I want to get to this point up here, which is 30 animals and 100 legs. So more legs, but fewer animals. Now, initially, a way to do this is to think of it in 2 parts. One is to move from 36 animals and 82 legs to 36 animals and 100 legs. We're just changing the number of legs, keeping the animals the same. And once we get to this point, keeping the legs the same, but making the number of animals less. So going from 36 animals to 30 animals. So let's see what happens. So reasoning through this, in this case, the first part, just want to get from this point here to this point here. Well, this gap between 100 legs and 82 legs is 4.5 cows. And how do I know that? Well, this is 18 total legs. And so 18 legs difference, 18 divided by 4 is this 4.5. I can get it by counting 1, 2, 3, 4, and 1/2, but also the 18 legs divided by 4 legs per cow is equal to 4.5 cows. And we know from before that as you move along these lines, as you look for the intersection between the number of animals and the number of legs, in this case, we're going to gain 1/2 of a cow because we're increasing the number of cows. So we're gaining 1/2 of a cow for each chicken. So we're going to keep the number of animals the same. So we're going to leave this at 36. And we're going to trade 1 chicken. So we're going to remove 1 chicken and add 1 cow. Remove 1 chicken, add 1 cow. And every time we do that, it's a net gain of 1/2 of a cow. So remember, this slope is -1. This slope is -1/2. So this gets closer by 1 unit or 1 cow in this case, but then this gets farther away by half a cow. We did this before, so it's a net gain in this case of 1/2 of a cow. So how many times can I do that? By the way, that's also 2 legs. And so if I want to gain 18 legs, it's 2 legs at a time, 2 legs every trade. So 18 divided by 2 is 9 chickens. So this is going to move over 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up to here. But also you can get that by realizing I have 4.5 cows. I'm going to trade. I'm going to add 1/2 a cow each time for each chicken. So 4.5 divided by 1/2 calculates out to be 4.5 times 2, which equals 9. So we're going to add 9 cows. Remember, you want to keep the animals the same number. So you're going to subtract 9 chickens. So add 9 cows to 5 cows. 9 plus 5 is 14 cows. And this total is going to be 36. So subtract 9 chickens. So subtract 9 from 31, it's going to get you to 22 chickens. You figure out the total number of legs, and it has to be 100 legs. 4 times 14 is 56, and 2 times 22 is 44. Add them together, you get 100 legs. And so you end up at this point right here, which is 22:14. So 22:14. So now we're at this point. So now I want to move from this point to this point. So now we're going to keep the number of legs the same. This is 100 legs, but we're going to move from 36 animals to 30 animals. So in this case, so these are the 2 lines, this line right here, and now this line right here. So as I remove 1 chicken, I'm going to add 1 cow. So what does that do as far as the legs? Okay, so this is adding 2 legs. So if I trade 1 chicken for 1 cow, chicken has 2 legs, cow has 4 legs, so I'm adding 2 legs, and this is keeping the number of legs the same. So this is 2 legs for the chicken and 2 legs for 1/2 of a cow. So that means I'm gaining 2 legs each time. So every time I make this trade, I'm gaining 2 legs, and this difference in the number of cows is 6 cows. Well, 6 divided by 1/2 is the same as 6 times 2 is 12. So it's going to be 12 chickens, and 2 times 12 is 24 legs. We actually never figured out the number of legs right here. So let's just keep it at, you add 1/2 of a cow each time. It's probably the easiest way to think about it. So this is a difference of 6 cows. 1, 2, 3, 4, 5, 6. 6 divided by 1/2 is 12 times. So for each chicken, you're going to add 1/2 of a cow. You're going to do that 12 times. So you're going to remove 12 chickens. But you're going to end up, so going from here to here, you're going to remove 12 chickens. But you're going to add 6 cows. 1, 2, 3, 4, 5, 6, which is 1/2 of 12. So reasoning through this, 6 cow difference, add 1/2 a cow at a time. So 6 divided by 1/2 is equal to 12. So you're going to add 6 cows from here up to here. So you're going to add 6 cows, and you're going to take away 12 chickens. So from 22 minus 12 gets you down to this 10. And so now we have 10 chickens and 20 cows. So how many total legs is that? 20 cows is 80 legs. 10 chickens is 20 legs. So now we've increased the number, we've kept the number of legs the same at 100 legs, but we've decreased the number of animals, because every time you trade 1 chicken for 1 cow, if you want to keep the number of legs the same, you trade 1 or 2 chickens for 1 cow. So you get rid of 2 chickens, add a cow. That's removing 1 animal. So you're keeping the number of legs the same, but you're reducing the number of animals from 36 animals to 30 animals. So that's this 6 cows right here and a minus 12 chickens right here. I want to show you solving this algebraically. So this is A. This is going from this point right here to this point right here, which is A. So this is the equation for these two lines, this line right here and this line right here. The equation for this line, which is 36 animals, is x plus y equals 36. And so rewrite that in the slope y-intercept form or the slope-intercept form. It's a negative 1x plus 36. The equation for this, the number of legs, is 2x plus 4y equals the total number of legs, which is 100 legs. We know that. So if I rewrite this in that slope-intercept form, I'm going to divide this 100 by this 4 right here. This is going to become a negative 2x, and the negative 2 divided by 4 is negative 1/2, and the 100 divided by 4 is 25. So now notice that the difference between these y-intercepts, this y-intercept is 36 and this y-intercept is 25. It's right here. This y-intercept is 25 and this y-intercept way up here off the page actually is 36. And those two lines are going to come down here and intersect at point A. So that set those two equations equal to each other. You get that same negative 11 unit difference from 25 to 36, and the difference in the slope is a negative 1/2. So this is a negative 11 divided by a negative 1/2, which is the same as 11 divided by 1/2, which is the same as 2 times 11, which equals 22. So now we're at this point 22, and the total number of animals is 36. So that means the total number of cows has to be 14. X plus y equals 36. X is 22. Y has to be 14. 36 minus those 22 is 14. And also, now to go from A to B, algebraically, the equation is still the same for the number of legs. It's still 100 legs. But now you have to use the equation for 30 animals, this equation right here. So notice that this y-intercept is 30. This y-intercept is still 25. So the difference now is 5 units, and the difference in the slope is 1/2. So 5 divided by 1/2 is going to give you an answer of 10. So notice you're going to get out here to 10. So this is what B looks like, going from this point to this point now. And we're going to use this line here for 100 legs, and this line here, the lighter blue line, for 30 animals. So notice that that difference is 6 units here, but the difference in the y-intercept is 5. It's up here. All right, so set those two equations equal to each other. So this is the new equation, x plus y equals 30. It was x plus y equals 36, but now we've moved it down here to x plus y equals 30. And the equation for the 100 legs is still the same. Set them equal to each other. The difference in the y-intercepts is that negative 5. The difference in the slope is still negative 1/2, but now that works out to be 2 times 5 equals 10. So the total number of animals this time is 30 animals. So if you have 10 chickens, that means you have to have 20 cows. So now we're at this point here. So notice we have solved the equation working from the left. So this was the this is the second one right here. Difference was 5 animals, 1/2 cow at a time. 5 divided by 1/2 is 10. So we're working from the left to the right. This was the A example. So again, working from the left to the right. This difference was 11. 11 divided by 1/2, or 11 times 2 is 22. Got us out to this 22. But it's weird to work from the left to the right when we started out working from the right to the left. We went from 36 animals and 82 legs to 30 animals and 100 legs up here. So is there a way to solve that, or to write equations to go from the right to the left? And that's the next part of this. So if you remember, I said that this gap was 6 cows. The gap between this line for 30 animals and this line right here for 100 legs. But the y-intercept, the gap for the y-intercept is 5 units. Well, I want to work down here. I want to look at equations that go in the same direction as the way that I'm reasoning. So likewise, if you look at this gap is 4.5 units, but the gap for the two equations, this line, or the y-intercept for the two equations, the two graphs, this graph goes up here to 36, and this graph goes here to 25. So that's a gap of 11 units. But I want to work with this 4.5 units. So can I write equations that go from the right to the left in this direction? Now this gets a little bit weird, but if you imagine moving the y-axis down to this line right here, so it's as if you're taking this whole graph and you're sliding it this way. So that's going to make this y-intercept right here 5 units. It's going to make this y-intercept right here 9.5 units, because 5 plus this 4.5 is 9. 9.5, sorry. All right, so now we're going to rewrite equations using this as the y-axis and figure out what this point is. What are the coordinates for this point? So it's going to be a negative x and still a positive y. So this equation, this is a y-intercept of 5 now. So it's x plus y equals 5. So that's as if you're working with 5 animals. Notice out here, it's 5 animals. It'd be 5 cows or 5 chickens. 1, 2, 3, 4, 5. And the number of legs is 9.5 cows. 4 times 9.5 is 38. So 2x plus 4y is going to equal 38, not 100, but just 38. So 2x plus 4y equals 38. So now if you set these two equations equal to each other, this 38 is going to get divided by that 4 right there. Well, first of all, this becomes a negative 2x. It's moved over here, and divide by 4, this becomes a negative 1/2 x right here. And that 38 gets divided by that same 4. That is 9.5 right here. And the other side of the equation comes from x plus y equals 5. So set those two equations equal to each other. And now this difference in the y-intercept is this 9.5 minus this 5. So it's this 9.5 minus this 5. So that's the same 4.5 right there. And that 4.5 gets divided by a negative 1/2 or multiplied by negative 2. So negative 2 times 4.5 is a negative 9. So you're going to move 9 units this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and remember that the sum of x plus y has to equal 5. So if this is a negative 9, then the number of cows, or y, has to equal 14. Because a negative 9 plus 14 is equal to 5. Now remember, we subtracted 31. We slid this all the way down here to 0. So we subtracted these 31 units. So you actually have to add those 31 units back. So 31 plus negative 9 gets you to this 22 right here. The y, the number of cows, is still 14. A little bit weird, but that's okay. Just hang in there. Let's look at it again. Let's look at it for this line now. Same idea. Now I'm going to make this line the y-axis. So what happens if I move the y-axis to here? So notice I'm taking this and sliding all the way down here. So the y-intercept now is 8. So this is as if you have 8 animals. So it's 8 this way and 8 this way. And you have 14 cows. And so the number of legs is 4 times 14 would be 56. And so if you have 56 legs, 56 divided by 2 is 20. 56 divided by 2 is 28. So this would go out to be 28 chickens if they were, anyway, doesn't really matter. All right, so this is, you write the new equation. So this is x plus y equals 8. All right, so this y-intercept is 8. So now I can write that equation, x plus y equals 8. So the total number of animals are 8 animals, and the number of legs is 4 times 14 is 56. So 2x plus 4y equals this 56. Now this 56 is going to get divided by that 4. So that's going to become 14. So this becomes a negative 2x. A negative 2x divided by 4 is a negative 1/2 x. And that 56 divided by 4 is 14. So now the difference between 14 and 8 is that 6 units right there. So 14 minus 8 is this 6. And you're going to divide that 6 by negative 1/2, which is the same as multiplying it by negative 2. Negative 2 times 6 is negative 12. So now you're going to go 12 units further this way. So from 22 to 10 is a negative 12. And the sum, the total number of animals is 30. So if this is negative 12, I'm sorry, the total number of animals has to equal 8. So if this is negative 12, then negative 12 plus 20 is equal to 8. So negative 12 plus y equals 8. Y has to equal 20. So this point is negative 12, 20. From right here, it's negative 12, and the number of cows is 20. But remember, we subtracted 22 units to slide this down to 0, to slide this down to the y-axis. So you have to add the 22 back. So negative 12 plus 22 gets you to this 10 right here. So this is 10 and then 20. So we've worked from the right to the left, both through reasoning and by writing equations. Now I know this gets tough because I'm moving the y-axis around. This is actually for the second one right here. But if you keep looking at it, keep thinking about it, it will begin to make sense, and it will make the problems in the future much easier to think through. Okay, we just showed solving this problem in 2 steps, going from here, this point right here, to this point in 1 step. So from 36 animals, 82 legs, to 36 animals and 100 legs, and then going from 36 animals and 100 legs to 30 animals and 100 legs. So 2 steps. Can you do that in 1 step? Can I write 2 equations that the graphs of those 2 equations will intersect at this point right here? Well, of course I can. I just have to connect these 2 points and write the equation for this line. So I'm going to connect these 2 points with this line right here, and now I have to just write the equation for that line. I already know the equation for this line. This is x plus y equals 36. But what's the equation for this line? Well, once I have 2 points, I can write that equation. I can figure out where this y-intercept is by rewriting the equation in the y-intercept form, or slope-intercept form, and then I can go from there. So first of all, let's check the slope of this using these 2 points. You can also count. So this is 7 units this way, a negative 5 units this way. So that means that it has a slope of a negative 5 over 7, or a negative 5/7, which is what we had before. But also, this is 20 minus 5. So this 20 right here minus this 5 is 15. And this is 10 minus 31. So this is 10 right here for the x value minus this 31 for this x value. So that 10 minus 31 is a negative 21. So 3 times 5 over 3 times negative 7. The 3's cancel. You get the same negative 5/7. So this slope is negative 5/7. So now all I have to do is figure out the difference from any point on this line. I can call that point xy. So it's going to be y minus 5 and x minus 31. You can use any other point. I could use this point as well, and xy minus this point. But I'm going to choose to use this point down here. This just reminds you where the number of legs are. And we're going to work from the left to the right now. Eventually, I'm going to want to figure out what this equation is working from the right to the left. So that would be this equation right here. And working from the right to the left. But right now, we're going to work from the left to the right. And this is the equation right here, y equals a negative 5/7 x plus 27 1/7. And I want to encourage everybody to just keep this as a fraction, and we're going to write it as an improper fraction, kind of go back and forth, but do not change it to a decimal. It will become very difficult if you change it to a decimal. So how do you do this? How do you write this equation? So if you remember, this length is y minus 5. You have to get rid of these 5 units. So you might remember the slope triangles from a long time ago. This is the y coordinate, and you have to remove these 5 units to get this length. This is 8 in this example. So 8 minus these 5 units tells you that this length is 3 units. So you can zoom in on this. So if I'm going to take this y coordinate right here and subtract these 5 units, I'm going to slide this slope triangle down to here, and that tells me that this length is 3, and then this length is taking the x coordinate and subtracting the 31. I'll get to that in just a second. So y minus 5, and that's that ratio, the length along the y-axis to the length along the x-axis. So now it's going to be x minus 31. So now I'm going to slide this down 31 units. I'm going to get rid of this 31. That's going to tell me this length right here, and it's going to be negative. It's actually a negative 4 1/5. I figured it out earlier, but just know that this length now is going to be x minus 31. So it's this x coordinate right here minus these 31 units. It's going to slide all the way down here, and this is going to be a negative value. So now this ratio, the length along the y-axis compared to the length along the x-axis, has a slope or a ratio of a negative 5/7. And so what that says is that the length along the y-axis is a negative 5/7 times the length along the x-axis. This is what we had a long time ago. So now I can simplify this. I can use the distributive property. This is a negative 5/7 x plus, don't worry about it, just work with the fractions. 5 times 31 is 155. This is a positive 155, and those are 155/7. So now I'm going to add 5 to both sides. Well, that 5 is the same as 35/7. 5 times 7 is 35. So it's 35/7. 35 divided by 7 is 5. So I'm going to add 35/7 to 155/7. 35 plus 155 is 190/7. I know it seems cumbersome, but just keep this as an improper fraction for a moment. So this is y equals a negative 5/7 x plus this 190/7. And so if you work that out, figure out what that is as a mixed number, is 27 1/7. So if you look up here, it makes sense. This is 25, 26. It's going to be 27 1/7. So this y-intercept is 27 1/7. This y-intercept from the first equation for the number of animals is 30. Because I rewrote this, remember I wrote this in the the slope-intercept form. All right, so now I can set these two equations equal to each other. This is the equation for the number of animals, so negative 1x plus 30. This is the equation for the green line. I don't know what that is exactly, but it's what connects these 2 points. And so this is a negative 5/7 x plus 27 1/7. All right, so now you're going to see that this gap is a negative 2 6/7. So it's a 27 1/7 minus 30. So it's 27 1/7 minus this 30. So this gap is a negative 2 6/7. And the difference in the slope, this is new. The difference in the slope is now a -1 minus a -5/7. Remember, this slope is a -5/7 right here, and the slope for the number of animals is -1. That difference is a -2/7. So now you're going to have 2 6/7 divided by 2/7, and that's going to equal this 10 right here. So I want to get to this 10. So continue to work through this. This -1 minus a -5/7 is this 2/7 right here. It's actually a -2/7. And this 27 1/7 minus 30 is this 2 6/7 right here. And it's actually a -2 6/7. So because they're both negative, you can write them as both positive. So 2 6/7 divided by 2/7. That's the same. So here it is, a -2 6/7 divided by a -2/7. That's the same as a -7/2. So you multiply by the reciprocal of a -2/7, which is a -7/2. So a -7/2 times 27. So I changed this to an improper fraction so I could cancel these. I could easily see that I can cancel these 7s. So now I have 20 divided by 2, and that is equal to +10. So that's this 10 right here. So if this is +10, the total number of animals is 30 animals. That means that this number of cows has to equal 20. So number of chickens is 10 chickens. Number of cows is 20 cows. And if you figure out the number of legs, 2 times 10 is 20. 4 times 20 is 80. 80 plus 20 gives you the 100 legs. So now, this is using the algebra to go from the left to the right. And the next question, and I know this gets tough, is can I figure out equations to go from the right to the left? If you remember, we moved the y-axis down to here. So that's what we're going to do in just a moment. We're going to move this y-axis to this point right here. Okay, so now can I write an equation instead of going from the left to the right? Can I write an equation down here that goes from the right to the left? It gets me to this point. So again, this is way out there, but it's okay. I can do that if I move this y-axis down to this line right here. Once I do that, so this is now 0. This is y equals 0. So this point right here, instead of being 31/5, is 1/5. And this point up here, instead of being 10/20, is a -20/20. So it's -20, 20, and this point is 1/5. And that's all I need to rewrite this new equation. So let's check the slope, and let's write this new equation. This equation is still the same, x plus y. Oh, actually, it's not. This is now x plus y equals 0. Not 30 animals, but 0 animals. So if I have a -1 chicken and plus 1 cow, that equals 0. And -2 chickens plus 2 cows, and that equals 0. So this is a new equation as well. X plus y equals 0. And this equation, 2x plus 4y equals, and I'm not sure what that is right now. I have to figure out what this y-intercept is. And I can do that because I know these 2 points. So let's check the slope. So now it's it's 20 minus this 5, and a -20 minus 1. So 20 minus 5 is 15. -20 minus 1 is a -21. That gives you the same slope of -5/7, which makes sense. It is the same slope. That's not changing. This is the new equation for the total number of animals. X plus y equals 0. So write that equation in the slope-intercept form as y equals a -1x. And over here, this is writing the new equation for this line. It goes through a new y-intercept at this looks very close to 6. Actually, it's not 6. And we'll get to that in just a moment. So let's use this point right here. So y minus 5. So anywhere on this line, y minus this 5. So that ratio to x minus this 1, so it's the same point, xy, that ratio of y minus 5 to x minus 1 is going to be equal to negative 5/7. It's the slope. Remember, this is moving those slope triangles, taking away 5 units, and now we're just taking away 1 unit to move this slope triangle to here. All right, so we can do a little bit of algebra in that it's y minus 5. That length along the y-axis is equal to the length along the x-axis. It's the negative 5/7 of that length. So negative 5/7 times x minus 1. So now you have y minus 5 equals a negative 5/7 x plus a positive 5/7. Negative 5/7 times a negative 1, positive 5/7. We're going to add 5 to both sides. So now we have a negative 5/7 x plus 5 and 5/7. So this y-intercept right here is not 6, it's 5 and 5/7. So leave this as a fraction. I'm going to change it to an improper fraction. So y equals a negative 5/7 x plus 47. So set this equation equal to this equation right here. So this negative 1x equals a negative 5/7 x plus 47. Hard to say. And the difference here, this is the difference in the slopes. Remember, that was a negative 2/7. And the difference in the y-intercepts is this 5 and 5/7. So it's 47. This is from here to here is 5 and 5/7. Another way to write that is 47. All right, so you multiply by negative 7/2. Negative 7/2, it's the reciprocal of a negative 2/7. The multiplicative inverse is the way that we used to talk about that. And so multiply this side by that same multiplicative inverse, negative 7/2. These 7s cancel out. They equal 1, and you're left with 40 divided by negative 2. That gives you an answer of negative 20. So you have y equals, and y has to equal positive 20, because remember that these two values have to add together to equal 0. So this is negative 20, positive 20. So this is a negative 20 and positive 20. So remember that sum, negative 20 plus a positive 20 equals 0, because x plus y equals 0. Now remember, we slid this y-axis, we subtracted these 30 units to slide this y-axis all the way down to here to make this y-axis here 0. So it's like sliding all of this part of the graph down to this point here. So you have to add those 30 units back. So it's a positive 30 plus a negative 20. This is negative 20 right here from this point, but you have to add the 30 units back. So 30 plus a negative 20 equals 10. So in the original graph, this point is where it was before, which is at 10, 20. The y value, the number of cows, doesn't change, but the x value, the number of chickens, does change. It goes to 10 from negative 20, because you have to add that 30. Now, can I figure out what this answer is, what this point is, through reasoning mathematically from the right to the left? And that's what's next. When I first looked at this, I wasn't sure how to reason through this mathematically, because I wasn't sure of this length right here. But then I looked at it, I now know the length. I now know that it's 5 and 5/7 from the equation that we just got done looking at. But I also know what this length is right here. So this length is 6 units, because this is a slope of negative 1. So I'm going to move to the right 1 unit, or 1 chicken, and down 1 cow. So to the right 1 and down 1. So this is 1 unit. 2, 3, 4, 5, and 6. And I know that this point is on this green line right here. And the more that I looked at this, I realized this is a gain of 5/7. This is 5/7 farther apart, and this is 1 unit closer. So you move 1 unit closer, but then again you move 5/7 of a unit, 5/7 of a cow in this case. No, actually, I don't know if it's a cow, but anyway, 5/7 of a unit farther away. So this is a gain of 2/7. So this 1 unit minus this 5/7 gives you a gain. This is 2/7 closer. And as you go this way, this is 2/7 farther away. So you move this way 5/7, and you move this way 1 unit. So it gets farther away 1 unit. It gets closer by 5/7 of a unit. So this gets farther away by that difference, 1 minus 5/7 or 2/7. Well, if this is 5 and 5/7 plus 2/7, that gets this to a length of 6. So that makes sense. Once again, this length is 5 and 5/7. As you move this way 1 unit, it's a gain of 2/7. So 5 and 5/7 plus that 2/7 gives you a length of 6. So now we can use that. From the equation, this length is 5 and 5/7 or 47. So we know that, and we also know it from reasoning, which I just showed you. But this length right here, we know that that length is 6 units. This length is 6 units either from counting or add 2/7 to the 5 and 5/7 that I just talked about. And that gets you to this value of 6. So 47 is 5 and 5/7 plus 2/7 equals a total of 42/7. 42/7 divided by, 42 divided by 7 is 6. So this length is 6 units. Once again, this length right here is 6 units. So the gap is closed 2/7 units for each chicken traded. So every time you go to the left 1 chicken or 1 unit, that gap is closed by 2/7 of a unit, which is the difference in the slopes. 1 minus 5/7 equals 2/7. So the gap is closed in 21 units, or chickens, if you want to call a unit a chicken. So this is 6. This gap is 6 units. It closes 2/7 of a unit each time, or for each chicken. So 6 divided by 2/7 is 6 times 7/2. You multiply by the multiplicative inverse of 2/7. So that's 6 times 7/2. 6 times 7 is 42. 42 divided by 2 is equal to 21. And actually, that's a negative 21. So you're going to go in this direction 21 units. From this 31 to 21, that gets you to this 10 right here. Y value, the number of cows, it has to add to 30. So if this is 10 chickens, the number of cows is 20 cows, because 10 plus 20 has to add to that 30. This is the line right here for 30 animals. And that's it. And I know this was long, I know this was detailed, but the more I start thinking about this anyway, the more I start to understand it. So I understand this stuff better than I actually ever have in my life after going through these activities.